Welcome to this week's Australian Water School Ice Swarm webinar titled A Powerful Feature of HECRAS Exposed. We're delighted to have Chris Goodell to present this webinar, accompanied by Craig Price, who's going to be a panelist with us. These two gentlemen are thought leaders in the modelling space, and we are fortunate to have them with us. So my name's Trevor Pillar. I'm the National Partnerships here at Ice Swarm, and I'll be chairing this webinar today. Well, that's us, and this is you, millions. It's fantastic to see so many joining us. Thank you so much across America, Europe, India, Asia, Australia, Southern America, and Africa. So fantastic. Thank you, everyone. It's lovely. We've got some up and coming free webinars you can see on the screen there right now. I won't go into each one, but the one I wanted to highlight was a course in Sydney specifically on HECRAS modelling, led by Craig Price and Mark Forrest and Dr. Robert Keller. You'll be delighted if you can come along to that. That'll be a fantastic training course. This webinar is concentrating on one part of HECRAS, but that course will cover 1D, 2D, the works. Getting right into today, Chris Goodell is a principal consultant with Kleinschmidt Associates, had over 20 years of experience with computational hydraulics, river hydraulics, and hydraulic design. Also a contributing author to the HECRAS manuals, and has applied HECRAS to a wide range of complex problems. So we're so glad you could be with us today, Chris. Also, Craig's going to join us as a panelist. Craig's a civil engineer and project manager in Surface Water Solutions, and has international experience in water resources, has an extensive software development and lecturing experience. His career includes 15 years developing hydraulic models for the US Army Corps of Engineers. And so there's a vast amount of experience with us today.
Now, I guess I did want to mention one thing about Monte Carlo analyses and some of the things coming up. This particular webinar that we're doing today doesn't focus on anything new, and I know a lot of the attention has been on new features of HEC-RAS. We had a previous webinar on that, and we will have future courses on that, including the one coming up, which will be the first one in Asia Pacific, taught off the new version. Lots of exciting new features. You can check out the variable time steps, the speed improvements. We'll have all sorts of additional abilities with internal boundary conditions, long culverts. All of these new features, if you want to learn them, come along to the live face-to-face course. We'll be covering all of those in detail. And if you can also express some interest for an online course that will be advertised the instant it's released, let us know. Send an email over to iSwarm, and we'll do that. We'll get back to you with some information about that online course. So with that,
right.
We can turn back over to you, Trevor.
Thanks very much, Craig. That's really good. And the webinars that Craig just mentioned are on our website. You can go to them, watch them. There's a couple of past webinars on HECRAS. And the other thing I would mention, Craig mentioned the upcoming future face-to-face course in Sydney. That's now on the chat line. If you hit your icon button at the bottom, you'll see a link to that course, and registering for that course is possible through that link. That's probably enough for the introductions. Chris, from Portland, Oregon, we're in your hands, and we look forward to hearing what you have for us in the next 20 minutes. So please, you could join us. Thank you, gentlemen.
All right. Thank you very much, Trevor. I appreciate that. And Craig, good to hear from you. I'm going to go ahead and begin my presentation. This is going to be a discussion on the HECRAS controller, which is, as mentioned before, it's not a new feature in HEC-RAS, but it is relatively unknown. In fact, some people don't even know it exists, but it's a powerful feature that comes with the HEC-RAS software that we have available to us to use to really enhance our HEC-RAS models and what we can get out of them. Okay, so we're going to talk about the HEC-RAS controller. The HEC-RAS controller is really just an application programming interface, an API, if you will, and it's a collection of programming classes. These are subroutines, they're functions, and these are things that you can call in a programming environment that will allow you to control the function of HEC-RAS. You can tell it to open, you can tell it to start running, you can set input data, you can change input data, you can retrieve output data, and you can make some logical decisions about what's happening with your software while it's running. You can access it by many different programming languages out there. Visual Basic for Applications is one of the most popular ones used, and that's probably because it's built into Excel, which most everybody has on their computer. I like to use visualbasic.net within the Visual Studio environment. That's a very powerful programming platform, especially if you want to do object-oriented programming. But I've heard many users use Python, R, MATLAB, and several others out there. So it seems to be that just about most of the popular programming languages out there can have access to the HECRAS controller. So what can we do with it? Well, there's, I mean, the applications are really limitless, but some of the more popular ones that I've seen being used and that I've done myself are automated control in batch mode running. If you have many hundreds or even thousands of runs that you have to do and you don't want to sit by your computer to press the start button each time, you can automate that process and come back the next morning. Real-time automated simulations with logic support. So in this case, you might be able to run your software in real time and monitor the output while it's running, make some logical decisions based on the output, and change your input in the middle of the simulation just by pausing the software as it's running, making the change, and then resuming it. And this can all be done automated using your computer program. Probabilistic analysis using Monte Carlo. Monte Carlo is a commonly used method for approximating solution outcomes using a pre-defined distribution of your input parameters. The problem with Monte Carlo, though, is it requires many tens of thousands of simulations, especially with a complex model like HEC-RAS. And so you don't want to sit around doing each one manually. It'd be nice to automate the process, and that's what the HECRAS controller can do for you. Optimization is something that can be done, as well as automated data processing. So how do we do this? Well, I'm going to demonstrate this in VBA with Excel, again, because this is something that just about every modeler out there will have access to. In fact, I like to tell people, if you have the HEC-RAS software and you have Excel, you have everything you need to do to automate and manipulate HEC-RAS through a programming environment. So in VBA itself, the first thing you have to do is go to the developer window where you see the code. Alt F11 is a nice shortcut key to get there. And when you're there, you add in a reference. And this is where we're going to add in the HEC-RAS controller. So go to Tools, References, and then you'll see, if you scroll down, HEC River Analysis System. You select the one that has the version that you're interested in. In this case, I'm using 503. Press the OK button, and now you've got that implemented as a reference, and you're ready to go in VBA. So when you're ready to start typing your code and you want to make use of the RAS controller, first you've got to create a new instance of it, and the command to do that is dim, then pick a variable, whatever you'd like, as new HEC-RAS controller. In VBA, it's really nice because as you start typing, you'll get this auto list members pop up, and you can actually pick from the list as you're typing, which is a nice convenience. Once you've selected the member of the HEC-RAS controller class that you want to use, in this case down below, I'm using the project open command. So this is going to open HEC-RAS for me automatically. It's going to tell you what argument is required of it to be able to run that command. In this case, it's looking for something called project file name. A lot of time, these arguments that pop up, they're very obvious what they're after. Sometimes it's not so obvious, and that's why I like to I'd like to plug the book that I wrote on automating HEC-RAS, because it documents every single one of these functions and subroutines and what all the arguments are and what they mean and how to input those into your programming language. But if you break down the HEC-RAS controller, you've got basically three different types. I mean, there's some others, but these are the more common ones we're going to use. You've got what I call the project subroutines, you've got geometry subroutines, and output functions. In the project subroutines, you have things like project close or open, and these are ways to manipulate the software itself. The geometry subroutines generally allow you to have some control over the input data. So you can set input, or you can even retrieve the input. In this case, I've got examples of where you might want to retrieve the reaches and the rivers in your geometry, or get a list of all of the nodes, all the cross sections. Maybe you want to get all of the Manning's n values, or even set the Manning's n values in your programming environment. Finally, we've got the output functions. This is where you're going to call output. After the software is run, you can go and retrieve just about anything you want, especially in the 1D part of HEC-RAS. Now in 2D, there's it gets a little bit tricky because that's relatively new to the scene, and the HECRAS controller hasn't been fully updated for 2D yet, but there are ways around that, and I'll show you that in just a second. But these are some of the more common output functions. The node output, that allows you to retrieve any output that you desire that's in HEC-RAS at a specific node. The next one, the reach output, that allows you to pick output for an entire reach. And finally, we've got the output DSS get stage flow, which retrieves output from the DSS file. And I'm going to demonstrate that in the example at the end. Reading and writing the text files is a very important part of controlling HEC-RAS. Not everything is in the RAS controller. So we have the ability to actually read and write to the input files that go into HEC-RAS. And you can see some of them listed here. The project file, the plan file, geometry, and the unsteady flow file, and the steady flow file. All of these can be read and written to in a programming environment. Okay, so here's some of the input files that you're able to write to, and you can see those in your project directory and open those directly in any text editor. Here's an example of the geometry file. You can see it's very complicated. There's a lot in there. It's hard to understand if you don't have all of the keys or know what everything means in there, but with a little practice, you can get that. This is the unsteady flow file. And in fact, this is the one in the example I'm going to show you that we're going to manipulate. We're going to read through this and then actually write a new precipitation hydrograph for each realization of the Monte Carlo run. So I'll show you that in just a bit. This is the plan file, another input file. And what's very important about this is knowing what these keywords mean so that you can find exactly what you need to find and what you want to change. And that takes a little bit of practice. A shortcut, if you don't want the practice or you don't want to put the time into figuring it out yourself, again, another plug for my book. I've got all these keys in the back of the book in Appendix B. And this will save you a lot of time because it tells you exactly what goes into each one of those keys in the geometry and the flow input files. It's also nice to build your own library of programming code for manipulating text. And you can see the one I've built myself personally over on the right-hand side that allows me to implement little scripts that I've already written that I use quite often for manipulating text in a programming environment. Now, if you do want to get 2D outputs, there is an option for that, but you need to be able to read HDF files. That's what the 2D output in HEC-RAS is written to. It's written to HDF files. Now, this is not implemented in the HEC-RAS controller, but we can have access to that by a variety of different online sources. There's a lot of work being done. HDF has actually become very popular. And just about every programming language out there is going to have built-in libraries that can read and write to HDF files. If you're using VB.NET, you can get all of the libraries you need right from the HEC-RAS program file directory itself, and then you'll use the h5assist.dll as your library, as your reference to read and write to HDF files. Similarly with VBA, Python, and others, if you do just a little bit of Googling around, you can find these libraries that you can use for your programming platform of choice. Now, on to the demonstration. So I want to show you real quickly how we can take a 2D mesh in HEC-RAS, and we can drop a rainfall event on top of it, and then read the outflow at the bottom end. And we're going to do this in a Monte Carlo experiment, which is going to require hundreds and probably thousands of runs to get statistical convergence. Okay, but what we're going to do is we're going to change the rainfall event for each realization. We're going to read the output, and then we're going to define probabilities of outcomes when it's all done. Now, I'm not going to actually run this now because it would take several hours to do it, but I'm going to go through the approach and then show you the results that I got. So in the probabilistic approach, I'm going to define a simple triangular precipitation event, and that's going to be uniformly distributed over the 2D area that I showed in the previous slide. Now for sampling, each realization, I'm going to sample a new precipitation event, and I'm going to do that by actually sampling the peak and then just stretching that precipitation event up or down based on the peak precipitation that I sample. And it's going to be defined over a normal distribution, which allows me to just input a mean and a standard deviation, and that's all I need to define my normal input, normal distribution. And then my software is going to, or my programming code is going to randomly sample over that normal distribution. Okay, so once I've gotten that sample, then I'm going to write the precipitation time series into the the unsteady flow text editor. Then I'll run the simulation and extract the peak discharge from the downstream boundary using the output DSS get stage flow function in the HEC-RAS controller. Then I'll repeat this over and over and over again until I get statistical convergence. And that'll allow me then to determine the probabilities of peak flow occurrence at the downstream end for a variety of different, or for the full range of rainfall events we might expect. So here's the code. I don't want to get too detailed here. I want to stay on time, but I've included this code so that you can go back through this presentation if you'd like to look at it in more detail. But let me quickly run through and show you what I'm doing. First of all, you notice all the green text in here. This is all the comments that I put in. I like to put a lot of comments in there. It just helps me when I come back later to understand what I did before, or if somebody else were to take a look at it, they can have a pretty good idea of what everything means in here. But if you scroll down a little bit past the first block of green, you see I have got this keep track of time block. This is just allowing me to time how long it takes to run this entire event or this entire Monte Carlo simulation. The next one allows me to define the normal distribution. I just put it in the mean and standard deviation. Okay, then I set a new instance of the HECRAS controller. I showed you this bit of code before, but this is an important part if you want to use the HECRAS controller. Then I set the HECRAS project that I actually want to use. So I have to set a string variable, and then on the next page, I'm going to define a bunch of variables that I'll use later. Then I'm going to start my looping process. So these are each of the realizations that I'm going to run. And in this case, I've got 1,000 listed here. While you're testing this code out, it's a good idea to do something much less than that, maybe 3 or 5 or so, so you don't have to wait around too long in between each test. Once you're happy with it, then you can go to the full 1,000 or so. Then I begin the realization. Here I'm going to sample about a normal distribution, the precipitation. That's what this SNGP variable is. I keep a running tab of the computed mean. Okay, you can also keep a tab of the standard deviation as well, and even the third and fourth statistical moments, if you'd like to get that detail. Then the next step is to apply that precipitation to the input file, the unsteady flow input file. This is what the input file looks like on the right-hand side.
5 minutes. 5 minutes, Chris.
Yeah, thank you, Trevor.
Yep.
Thank you. So you'll open one file, the actual unsteady flow file, as your input, and then you'll open a blank file as an output. So the input is the one you're reading, the output's the one you're writing to. So you can see the input file on the right. And then basically the way this works is I search through line by line, and I'm going to copy each line and I'm going to paste it into the output file. But when I get to the line that says precipitation hydrograph, that's the key that I was telling you about. That tells me I've got to the spot where I can enter in my new hydrograph that I've sampled. And so here you can see once I've found this precipitation hydrograph, then I'm going to print a new line that has the sampled precipitation peak value listed there. Okay, so it's basically going to rewrite this line. Every other line in this text file is just copied and pasted. All right, so once I'm done building that, I can close those two files, and now I'm ready to open HEC-RAS. And make sure you open HEC-RAS after you write to your input files, otherwise that new data won't be read in to HEC-RAS. Okay, so you open HEC-RAS, then you go ahead and compute it, and at the end of the computation, we're going to extract the output from that downstream cross-section, and that's what this RC output DSS get stage flow command does for us. It reads the river, the reach, the cross-section river station ID. Then it returns the number of points in the output hydrograph. It returns a date and a timestamp for each point on the hydrograph, and then it gives you stage and flow for each point. Okay, and then there's also an error message you might get. Once you've got all of those points on the hydrograph, then we want to retrieve the peak flow. So this is just a little bit of script here that will retrieve the peak flow from all of the flows in the hydrograph. Then we're ready to quit RAS, and it repeats over and over again. Once it's done with all of the realizations, then all we need to do is sort all of our output. So we're going to sort our peak discharges and our precipitation values. And once they're sorted, now we have a list of peak discharges that we can pick values off to get exceedance probabilities. It's as simple as if you have 100 outputs and you want the 1% exceedance probability, you pick the one at value number 1. If you have 1,000, it would be value number 10. So you're just picking the percentiles, basically. And that's what this does here at the bottom of the code. And then just to wrap up, I printed out in a message box so I can see what the results are. And this is what I've gotten when I ran the 200 realization Monte Carlo experiment in the 1,000. And here you can see we've got the 99% peak discharge. It gives you the peak flow, and it tells you the precipitation that was dropped on the watershed to create that peak flow. And we've got it all the way down to the 1% here, 163 cubic meters per second with 1,300 millimeters. It also lists the computed mean of all of the input precipitation. Now, my input mean was 750, if you remember a few slides back. And so ideally, you would want to run this long enough to get that value down to your input mean, in this case, 750. Notice when I do 1,000, I get much closer. My guess is if I were to do 2,000 realizations, I'd probably nail the 750. All right, I sped through that really quick. I hope you learned a lot. There's some Q&A, so we can continue on discussing this with any questions you have. Just once again, if you're interested in that book that talks about how to do the HECRAS controller, how to automate HEC-RAS, you can go to my website that's shown at the bottom, therassolution.com, and that'll show you exactly how to get that. I've also got available the HECRAS controller code workbook that actually has all of the code in the book, plus much more included in a Excel spreadsheet that you can download and have everything right there ready for you. You don't have to retype any code. You can copy and paste out of it and do whatever you'd like. And I've left my email at the bottom as well if you'd like to get in touch with me.
That's fantastic, Chris. Thanks so much for all of your work on this. It's been such a great run through on that HECRAS controller. Craig, your thoughts?
Yeah, and I guess before we go too much further into the detailed questions, I wanted to maybe point out that there are probably two groups of people watching this, either live or watching this in the future. One group will write a line of code in the future. One group, probably like me, will never write another line of code the rest of our careers. I may get into this in the future, but what's important is that you know that it can be done and that you can find people who can do it. So once you know that, then you know when you're setting up your projects that there are people that you can go to that can do this and customize it and automate it. One of the reasons we picked this topic for IceWarm, being an Australian entity, is the new guidance from Australian Rainfall and Runoff to do ensemble modeling and Monte Carlo analyses for your hydrology. Now that rain on grid and direct precip models in hydraulics are becoming so much more prevalent, that's why we went back. With all of this attention on new features and new capabilities, why would we go back to something that's been around forever? Well, the reason is because the computing power and everything is getting so good at doing these gridded rainfalls and new hydrologic analyses in a hydraulic model that you're going to want to be able to access this powerful feature to be able to do that. And so I just wanted to, make a plug for that. There may be some people out here who, when you think of Monte Carlo, you're thinking of a car, a casino, a biscuit. If you're one of those types of people, just realize it means running it a lot of times over and over and over and over again to get the statistics out of it. That's what it means. And yes, HEC-RAS can do it. A lot of other software has further capabilities in doing infiltration and some other capabilities that will be coming in future versions of HEC-RAS. At the moment, though, the most powerful piece of this that I see applicable, at least to the Australian industry, is that you can take all of your rainfall patterns, put them all together, batch it all up, and you walk away and let the computer do the work. So with that, then let's turn it back over to the attendees to ask some technical questions.
Yeah, we've got a few coming in now. Thanks a lot for that, Craig. That's excellent. And whatever we say here over this next discussion point, I just wanted to reiterate that in June 4th to 8th, there will be a face-to-face course in Sydney for 5 days, and you can come to a 1D course or a 2D course or both courses. We'll plug that more later on. Henrik Olander writes, "Hi guys, this might be a bit off topic, but does any of you have an estimate of how many active HECRAS users there are around the world?"
I don't know if anybody can do that, can have a really accurate estimate of that. What I can tell you though is I do notice a lot of users on my blog, the RAS solution, from all over the world, and I get about 30,000 page views a month. So I don't know if that helps to give you an estimate, Henrik, but I really couldn't say. I don't know, Cray, if you have a better idea. I've talked to the people at HEC, and they do track downloads. So if you really wanted to get a number of downloads that they've had of the software, then you can check with them.
Yeah, no, that's true. They Gary does check which countries the downloads come from, but that doesn't include all the people who just download it and then pass it along to their colleagues. So it's not really a great estimate on how many people there are. But yeah, when we had that wormhole culvert hack, I probably had 15,000 to 20,000 hits on that. Yeah. That gives you a feel. I would guess, if I had to guess how many installations there are out there, I pulled a number out of the air, I'd say 50,000, but that's just a guess.
The next question. I saw an output box. This is from Matt Marquis, who says, "I saw an output box from Excel in the presentation. Do you have control over how your output is shown or presented / organized?"
Yeah, and it's going to vary from programming language to programming language. In VBA, which is what I demonstrated today, you can you can show your output in a number of different ways. I presented it in a simple message box or output box. And it's just a real simple command inside of VBA to do that. In fact, if I can share my screen, Trevor, I could show that real quick. And at the very bottom, you see this command, message box, total time, and then it writes out the string that I wrote just above. So it's a simple command that just says message box. And then when it gets to that point, it pops the message box, and that message box will stay up until you click the X. But you could also, the nice thing about VBA is you could also write it to an Excel spreadsheet. That makes VBA extremely powerful, because then you can compile all your data in one spot, and then it's ready to do whatever you want to do with it after you're done with your run. So I hope that answered the question.
Yep. Thank you, Matt. Thank you, Matt. That was Matt's from Ohio in the US. Harlan Associates. That's great. Thank you for that. Henrik Olander asked another one. On how many projects have you, Cray and Chris, applied the use of the controller, HECRAS controller, and more specifically, for how many projects have you used Monte Carlo runs?
Boy, it would be hard for me to give you a number, but I would say probably a few dozen so far, actual projects, and then I've done a lot of just fooling around stuff, of course, with it. And how many I've done Monte Carlo? Actually, I should say that was the Monte Carlo type stuff. HECRAS Controller, I don't know. I'd say in the hundreds. I probably have used it to some degree. But yeah, with Monte Carlo, maybe a couple dozen total. And then I've got actually 4 projects I've worked on recently where we've used it for dam break modeling.
Sounds good. And Cray, yep, your comment?
Well, yeah, no comment on that, other than I have not seen it used yet on a project in Australia, which is why we've decided to bring Chris in. I believe it will be a very useful tool to comply with recommendations in ARR going forward. And if you ask this question a year or two from now, I think we would have a lot more. At this point, everybody's running Monte Carlo and ensemble modeling. This will help make it more efficient for those HEC-RAS users.
Great to hear from you, Henrik. Thanks very much. In Sweden, Gothenburg in Sweden, that must be an unusual time over there. It's 11:30, 12 midday here in Australia. David Gonzalez Diaz has asked, the batch mode means run several plans one after another, and there's an option to do it automatically in HECRAS. But there is an option to do it all at the same time is there an option to do it all at the same time with the RAS controller?
Yeah, I think I understand what David's asking. There
Yeah.
is inside of HEC-RAS, there is actually a command that will run all of your plans that you've set up. So that's a way of doing a batch mode run. The problem with that is you have to set up each plan individually ahead of time, and it just runs what you have already. In the HECRAS controller, what you have the option to do is change the input between each run if you'd like to do that, and run batch mode that way. So that's the difference between the two.
That's good. That was David from New Delhi. Suresh now from, no, I can't see where you're from. Sorry about that. I had your name here a moment ago. But look, Suresh has asked, will the free version of HECRAS and its updates continue into the future by the US Army Corps? That's a pretty fundamental question from Suresh. Thank you.
Yeah, there's no interest in changing that by the government, U.S. government. So as far as I know, it will continue forever.
Sounds good.
Yeah.
No, that sounds fantastic. Singapore, Suresh is from here, Singapore. That sounds great, and that is one of the great things about the US Army Corps making it available. Pankaj has asked, we're going through quite a few questions here, but Pankaj has asked, how can I use HECRAS Controller to automate RAS mapper commands?
Yeah, that's a good question. Unfortunately, the HECRAS controller, at least in the current version of HECRAS, does not have any procedures built in that directly manipulate RAS mappers. So I'm afraid if you want to do something automated with your spatial output, you might have to do that in an ArcGIS environment or QGIS or whatever you use for GIS, and take advantage of the scripting capabilities in that software.
There's a great question come through on the chat line, Chris and Cray. It's from Rahul in Baltimore in the US. Thanks for your presentation. I came across a technical paper somewhere where they used HECRAS Controller to modify the reservoir operations. Yeah? I was curious how often it's used like that for dam projects and how complicated it is.
I don't think it's very commonly used, and I don't think that's because people don't want to use it. I think it's not very well known, to be honest with you, which is one of the reasons I was excited to do this webinar. So I think it has the potential of being used very often on dam projects. When you start talking about optimization of some of the outlet works at dams, dam break analyses, which I've done a lot of, use the HECRAS controller for that. So I think the possibilities are endless there, and probably we'll see more and more of that as we go forward.
Yep, another one coming through now on the chat line, but if you could, everyone use the Q&A and make it a bit easier for me to see which panel I'm looking at. That's all right, though. It's fine. Lovely to have the questions, and thank you very much for them. Chris from California says, what agencies in the US, in your experience, have been open to a Monte Carlo type analysis? I've seen some languages in FEMA, but there are other agencies open to this approach. Are there other agencies open to this approach?
Yeah. Hey, Chris. I know from personal experience that both the Corps of Engineers and Federal Energy Regulatory Commission in the U.S. are not only open to Monte Carlo, but they're embracing probabilistic analyses and moving forward fairly aggressively.
Yep. Elangovan asks, in future, will HECRAS combine the HECRAS HMS into a single platform?
I don't think that there are any plans to do that in the near future. But what HEC is doing is they're providing software that serves as sort of an umbrella program where you can plug in HEC-RAS and HEC-HMS and others so that they can all be run under a single platform. And it's called CWMS. That's the Corps of Engineers version. RTS is a publicly available version. And they also have a long-term planning program in development called the WAT, W-A-T. All three of those actually allow you to plug in both HEC-RAS and HMS and other software that HEC develops into a single simulation.
Yep, that sounds great. Eric asks, how are you using this for dam breach analysis?
So those of you who've done dam breach analysis recognize the high degree of uncertainty of the dam breach input parameters. And for that reason, I think doing probabilistic analyses is a much better way to go. It's a better way to present the information. So the way this is done is similar to the example program that I showed in my presentation. Instead of changing the precipitation values for each realization, you're going to change the dam breach parameters. And then what you do is you sample the output at the dam itself, the outflow hydrograph, and you can then assign exceedance probabilities to the peak flows that you get at the dam.
We got a ton of questions, so thanks so much for keeping brief answers. And I might add that this will be in depth, highly in depth, in the week we're running this training over in Sydney in June 4th. Mark Pauls from Houston, Texas asks, are there additional complexities with modifying gate operation rules, or is this easily accessible through the text files?
It's pretty easy, actually. Once you know the keys in the text files, it's actually fairly easy to manipulate the gate openings, and those would all be stored in the unsteady flow input file. So yeah, I don't think there's a lot of complication to it. It's pretty easy to do in my experience.
Yeah, Simonson, also from the US, Gill Engineering. Could the HECRAS controller be used to iterate on inputs like Manning's N, etc., for the sake of identifying the cause of warnings?
I think I understand by iterate on inputs. If you mean changing the inputs between each run, then yes, it can do that. I may not be understanding your question exactly. If you want to post it again, if I didn't get that right, please do.
By all means, yeah. David?
Let me just throw in there, if there are questions about sensitivity analyses, everybody needs to do sensitivity analyses on roughness. You shouldn't turn in any model that hasn't had sensitivity values or assessments run on it. If you're just doing sensitivities, you probably don't need to get into this much detail because you can just set up your own batch runs and let it go. But if you need to have a whole range of variables going on, it may be worth it. Also wanted to mention 1D versus 2D. It's going to be much more efficient to do something like this in 1D. The 2D timeframes that are required to run a decent model in 2D, running thousands and thousands of scenarios in 2D probably isn't even an option for you. So when you're doing dam break, you may want to take your 1D reach, like Chris mentioned, and run your Monte Carlos on that. Once you know the output, then you can choose which ones to run, but you're not going to want to do thousands and thousands of runs that map your downstream floodplain. And a lot of times you won't have answers for 10 years if you tried to do that.
That's correct, Cray, and I'm glad you brought that up. And so to make it a practical exercise, what you really have to do is you have to truncate your model. So you're just including the reservoir, maybe a little bit of the downstream reach. And there's some other techniques you can use to speed things up. But basically, you're looking at trying to get a HEC-RAS run to go under 5 seconds. And those of you who've done a lot of HEC-RAS modeling know that that's pretty rare to get a model that runs that quickly. But if you can truncate it properly, and if you're interested in doing that, shoot me an email. I can give you some tips on how to truncate it. And get it under 5 seconds, and you're able to do, you could do an overnight run of 10,000 realizations and have your results ready the next day. I've done some 2D model, dam break models using probabilistic approaches, and have had runs go 2 or 3 days long, but that's about the end of my patience there. So that's about my limit, and I'll try and get it at least small enough or truncated enough to go that fast.
David from New Delhi says, how much time can a dam breach analysis take with uncertainty analysis using an entire 2D modeling in HECRAScontroller?
Yeah, of course, it's going to depend on the size of the 2D area, but even if you have a modest sized 2D area, it's going to take a very long time to do Monte Carlo and be able to get statistical convergence. So that's why I recommend, again, truncating your model. And you can truncate your 2D area as well. And once you have the exceedance probabilities, as Cray mentioned, then you can rerun those, only those, in the full model and do your mapping off of that.
Sounds good. Henrik, I see you're in Melbourne, not Sweden, although you sourced in Sweden. You're currently in Melbourne. on Australian stormwater management. That's great. Thank you for that note. But you had another question following up. Thanks for the answers, guys. Just one more question. As a newbie to Australian Rainfall Runoff 2016, how does Monte Carlo runs tie into the recommendations and rules framework of ARR 2016, more specifically? Yeah.
Yeah, and I guess this is where we have to stress the limitations of the software right now in its current version, and also the new version coming out in the next few weeks, hopefully, will not have the full capabilities to do what some of the other software can do. And we need to be totally upfront with people who are selecting a model and say it cannot do certain things that you're going to need to do to comply with ARR recommendations, because you would need to be able to build in spatially variable rainfall with gridded rainfall coming in. Like Chris mentioned before on his model, you're stuck with a single pattern over every 2D area. So you would need multiple 2D areas to get spatial variation out of it. And infiltration capabilities right now are limited at best, and you're not going to be able to do that. You only put in rainfall excess. So you can comply with certain recommendations once you've got your rainfall patterns, but you've got to do a lot of work up front before you start running HEC-RAS, which some other software is able to do all built in. In the future, version 5.1 I've heard is going to have a lot more infiltration capabilities, but I don't think that's out until at least mid-2019.
Sounds good. Yep, thanks for that. Garrett Johnson in Texas says, have you ever used Python to script HECRAS controller? I saw online in your presentation about DSS and HDF Python models.
Yes. So personally, I don't yet know the Python language. I'm very familiar with it. I've had staff that have used Python to script HECRAS controllers. So, and then I've had a number of people who have either discussed it on the blog or I've talked to directly that have used Python. So yes, it is definitely possible. I probably would not be the best one to give you Python advice, but I do know it's possible. And by the way, I didn't mention this before, but on the RAS Solution blog, there's a forum there and a sub-forum in the forum that is specific for HECRAS Controller. And if you get into that, you can ask questions, you can answer questions, and in there you'll see all the different programming languages people are using, from Python to R to MATLAB, and then of course, you know, VBA and Visual Basic, VB.NET, and several others. So you can look in there, and that's a great source for help if you're having trouble with it.
Thanks very much. Look, the last question, time is running against us. Matt asks, is it possible that during the course of the Monte Carlo simulations, a run will become unstable? Will the simulations continue, or will that kill your program?
Yes, it's possible that a run could go unstable, and good practice would be to do enough testing up front to try and avoid that as best as possible. But if you're doing it and a run does go unstable, what happens is you just get returned a very weird number. And sometimes it's not weird. Other times you don't get a number at all. But that doesn't kill your Monte Carlo simulation. It just moves on to the next realization. And then when you scan through your results, when it's finished, you look for these numbers that look a little bit weird. And then you can always go back in and replicate that particular run and see if it indeed did go unstable. And if so, then you can either run one more or do the whole set again after you've done a little bit of testing.
I think we should begin to close down now, but there's just a couple of points here I'd like to make. One is about your book, Chris. We should give that plenty of airing. One anonymous comment here is, I tried following the breaking book, but got stuck on page 7. My version of Excel did not provide the project on the menu bar. Is there something missing? I was running Office 7 rather than Office 10. Should we answer this in a chat way or get an email to you from this?
Yeah, I saw that. I saw that a little bit earlier, and I was thinking that I'm going to have a tough time answering that right here in this setting. So I would recommend that person, yeah, just send me an email, and we'll work through it.
Sure, and if you haven't got Chris's email address, I think send it to us and we'll certainly get it to Chris and Cray. No problem at all. Yep, thank you for that question. There's one last statement here from Eric, and it's a good statement. Thank you, Chris and Cray, on the discussion of 1D and 2D on this topic. I'm doing 2 dam breach analyses, but we'll definitely look at using the controller in future projects. So I think that's just about sums up the webinar today. That the controller obviously piques an interest, and going by the numbers of people that stayed on board for the entire nearly an hour, then I'm really pleased to see this controller is of some use and interest. So that's been great. Any other closing comments, Craig or Chris?
I guess one thing I wanted to mention is that if we are planning on doing future webinars like this, and we'd like some input. I had a couple of ideas for what we might do. I know I'm working with a lot of agencies doing rating curves for gauges. If anybody wants to see an application of taking HEC-RAS and pulling a rating curve out of it and running sensitivity analysis on those, that might be good. Dam break, we could do a demo of a dam break model. There are hundreds of topics we could cover. If you want to submit your ideas for what you would like to see, then we can focus on those things that would be most relevant. The next one I think will come out just after HEC-RAS 504 is out, and we'll probably focus on one of the new tools in 504. For example, building a 1D reach right in RAS Mapper. That might be a good one.
So, and if you want to communicate direct with myself, tpiller@iceform.com.au, it's on the website, for webinar website, you'll see it there, or go straight to Chris or Craig as you wish. But we'd be very interested in your comments about how we take this webinar series forward regarding HEC-RAS. There's obviously a lot of interest, huge amount of interest. But for today, I think we're going to have to call it that. Feedback survey form will come up to you in a moment. The recording will be emailed to everyone. And there's 3 webinars coming up there. You can see Sustaining India's Hidden Water Resource next Thursday. And then a few more coming straight after that. But the main thing, as I said, was that yellow highlighted HEC-RAS water modelling course in Sydney. We'd love to see many as can possibly come to that to join us. Keep in touch with us on Twitter at Iceform. We look forward to your joining us again at the next webinar. So glad to have you with us, and thank you very much, Chris and Craig, for your time today in far-flung places. There it is, the view of Curzon City, and Chris, thank you again both so much for your time and energy. Goodbye, everybody. Thank you for joining us.